Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at a new foundational vision model called Florence-2 by Microsoft. Florence-2 is built for computer vision and vision language tasks. Earlier, Microsoft in 21-22, they released Florence, which was based on two-tower architecture. We're gonna also have gonna compare Florence with Florence 2 as well. So Florence 2 is not the first model in the Florence series. Earlier, they created Florence for computer vision, and that was based on coswin and bot like image encoder and so on and so forth. Now Florence 2 is an unified based on an unified architecture, so it's an unified we can say a model that can do a lot of tasks related to computer vision, tasks related to multimodalities when it comes to visual question answering, visual action recognitions, captioning, object detection, etc. Now I'm gonna show you how you can inference Florence 2. I'm gonna cover the research paper, show you the technical nuances, explain a few things in detail, and then we go into the fine tuning step. So I'm gonna cover that. It's going to be a lengthy video. So if you are someone who does not want to follow along, you should not watch this video. If you are someone who wants to understand, Florence 2, the architecture, how to inference and fine tuning, then this is the video for you. Let's jump in, guys, here. So if you look at on my screen, I have the research paper called Florence 2, advancing a unified representation for a variety of vision tasks. Microsoft, and earlier they had Florence. So you don't think that this is the only. I think if I can just do archive, yeah, in 2021 by L Yuan or Yuan, whatever. So you should know about these things. It's not a new thing that Microsoft is working. They have Project Florence that they are working for many years now, and the Florence 1, Florence 2, and we might see Florence 3 in near future. So I have done a deep study of Florence as well previously. You can look at these research paper. I loved these in 2022 because of for that year 2021 2022 this was a very advanced model, to be honest, if you look at Florence. And now we're going to talk about Florence 2. Over here you can see this guy is common, in both the paper, and of course there are other guys who are common as well. But yeah, so the same team who have been working, they have been doing their research. First of all, that's how it happens when organizations like Microsoft forms a research team. You can see Azure AI. Now we're going to look at a few things here, guys. So model is here, Florence 2 large, more than 100,000 downloads already in a month. It's a new model last couple of weeks, so very successful. And the great thing about is MIT license. MIT, you can make money out of it. You can build software projects, sell, and make money, using this model. So it's MIT. We're gonna use this for inference, and we're going to use this data set called science question answering, which is an MCQ based question, multiple choice questions, for fine tuning. So these two things are important for you to understand. And I have my tab on, so I'm gonna explain Florence 2 here in detail. But let me first show you the notebook, and then we go into the theoretical part of it. So these are the downloads that you have to do. I mean the install, excuse me, you have to install these libraries. These libraries are for fine tuning, by the way. Yeah, but good to install it in the first sale as well. Otherwise you have to restart later on. I have some imports from transformers. We are using auto model for causal and auto processor. And for visualizing the images, we have pillow. Some color maps, because we're going to have a look at the bounding boxes and stuff. So that's why we have these imports, matplotlib and stuff for visualization. Defining the model ID here, which is Microsoft Florence 2 large. You just have to go here, copy, and come here and paste in the cell. So basically you have a model ID ready. I've logged in already with my Hugging Face thingy here. So you need a key. Basically, for trust remote code true, if you have this on, and also if you want to push the fine-tuned model back to Hugging Face, then you need to have a right privilege on Hugging Face to do that. Now, to load the model, I'm using auto model for causal LM, and that I'm using dot from pre-trained. The reason causal LM, because it's a text generation. It's a generation task. It's not a mask language modeling or MLM where you're gonna fill something or fill a missing token. So that's why we are using causal LM over here. Device map CUDA, the reason being because we're utilizing A100 GPU on Colab Pro over here, you can see, and the auto processor of the same params. All the model pipelines can be seen here. It has been downloaded. Now I have a function that's called run example. Now how do we inference, guys, Florence-2? Because it asks you which task you are trying to execute. So you can define a task which is unified. So based on the task instructions, it basically execute the model. So if you look at here, we have task prompt where we are giving the task prompt and the image over here as an input param. If you give prompt, basically, it has to tokenize and create IDs. You can see it over here. And for the image, you have to create a pixel values. So these two lines that you see are nothing but the numerical representations of different dimensions of data. So text being one, the image being the other, and they are all numerical representations. You have to understand these guys. These are the fundamentals. Max new tokens 120, 1024, excuse me. So the new tokens would be around 1000 and couple of other inference params that you can understand. If you want to stop it early, you can do it, blah, blah, blah. Then I have decoding it. Once you get the ID, you have to decode that, skip special tokens true, whatever you do it over here, false. And then you have parsing the answer here for the passed answer and then return. So that's a function. Now, I'm going to use local images to try it out. You can also use URLs, by the way. If you have some images on URLs, you can do that. Here I have from PIL import image, and then I'm giving the local image path. So you can see I have an image of text JPG. You can see this is the image text. And what I can also do, let me just show the other as well, because I already have tried this. So I have something called radio log report. So let me just take this image, and then I'm using Pillow to open it. You can see here it's a bit big file. It's like 2 MB size, so it takes a bit of time. You can see this is something that I found from internet. So I'm not uh, leaking any PHI information. This is something available on Google Images, so I just took it. I don't know how it's available, but anyway, it's a X-ray of chest that we have for a patient, and there's something going on, okay, over here. So now you can see this is how you create task prompt. So for example, if you need a caption for a given image, then you have to take a quotation, and then you have to follow this pattern and then define it caption. Everything should be caps. It's available on the docs. And then run example where I'm passing the task prompt and my image. And if you look at this, it's going to say something about chest x-ray. You can see it says chest x-ray image of a man's chest, which is fantastic. Now it also has a detailed caption, same caption but in more detailed manner. So for example, if you want a one-line summary, or if you want a detailed caption of your given image, then you can also do that here. It says the image shows a poster with an X-ray image of a man's chest along with text, barcode, QR code, blah blah blah. The poster is likely advertising a radiology imaging center in Mumbai as indicated by the text. So it understand the nuances, guys, both the spatial and semantic granularity and everything. I'm going to explain that in a bit. These are the jargons, but I'm going to keep it simple. Now it can also process the location tokens, the object detection part of it. So when you run this in the image, this person has, like, it says person, but it's like a skeleton of a human being, but it's still a human in the end. So it says person over here. You can see it right here. Now the next is it also supports OCR, guys, out of the box OCR, which is really fantastic because OCR is one of the most complex problems to solve when it comes to natural language or machine learning ecosystem. And if you look at here, it has both the support. It can extract text from a given sample, and it can also draw the bounding boxes. So basically OCR with region as well. That's what it also supports. Now if I'm going to do this, you can see how beautiful extraction. Basically, you have to format this. The formatting needs to be done, but yeah, it's able to get it what it has to. And then it also has OCR with region. Okay, so it also brings up, it does the bounding boxes, the rectangles over the text that it has to extract, and it also performs that as well over here. And these features are available out of the box, guys. And if you look at here, this is fantastic. Now it's able to find out uh, all the elements, and then it basically creates the bounding boxes. You can see it how good is this, guys, right? But probably we have to check the multi-table invoices or something where we have multi-line tables, excuse me, not multi-table, multi-line tables, because that's where the OCR struggles mainly. A lot of OCR engines, they struggle with that. Now, it also has OCR, as you can see. Now we're gonna come to fine tuning, but let me explain back. So this is how you inference. Inference is quite easy. Just define, uh, install some libraries, then import the libraries, then define the model name. Then we're going to use auto model for causal lm dot underscore from underscore pre-trained, and then the auto processor, and then just load the model and do an inference with the function that they have given in the doc. That's how easy the inference is. You can use a lot of other you know uh, frameworks and libraries like VLLM, Unsloth, blah 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 to do that if you want a faster inference as well. If the model supports. Now let's go back and see our main thing, which is Florence-2, guys, here, right? And I'm going to explain that a few things here in Florence-2. Florence-2. Okay, so let me just take this. What should we do? So the first thing that I'm going to write here is that this is unified. So it's unified vision model or unified. The better to write foundational model because uh, you can also basically fine tune it for downstream tasks if you want, and that's the main agenda of this, right? Because then you're gonna fine tune, for a lot of downstream tasks. So basically, it's an unified thing. So unified vision foundation model, it can do. Let me just write it over here. Foundation model. So it can do both CV and vision language task, both the thing. Now, what do you mean by what do you mean by the word unified? So unified is prompt-based representations, like based on prompt instructions. So prompt-based representation. That's what it does, prompt-based representations. Now, what are the tasks that it can execute, guys? So the tasks that it can execute are various. So the first is it can do captioning. The second is object detection. And then third is, of course, visual question answering, which is VQA. And then I'm going to write segmentations. It can also do grounding, blah, blah, blah. So these are some of the tasks that it can do. So it can cover a wide variety of tasks, where you start with computer vision based tasks and also the uh, multimodalities when it comes to AI assistant and all of those things. It can also do that. I want to cover a few key concepts before we go into the fine tuning. So let me just do key concept here. And in key concepts, the first thing that you're going to do is uh, data. We're going to talk about the data. So if you talk about the Florence model, the first variant of this model, which was released in 2021, if I'm not wrong, it was 900 million text image pairs, which was curated from 3 billion text image pairs from internet. That was the first series, first model in this series, which is Florence. Now, if you talk about Florence 2, 5.4 billion annotations in on top of 126 million images. So it's that huge. So 5.4 billion annotations. But if you compare that with Florence, this is humongous. Now Florence, as I said, right, only the Florence first model about 900 million text image pairs out of 3 billion. And the reason that they do Florence that did it, guys, in Florence they had a lot of filtering. Here also they used filtering, but here they used automated image annotation. So let me just write it over here. So they use, according to the research paper, they had automated uh, image annotations. That's what they talk about. And then, of course, some model refinement. This is written in the same thing. So I've just explained this. Yeah. So because for doing a manual annotations of such magnitude, like 5.4 billion, which is humongous, right? Not, I'll not say it's not possible, but yeah, it's doesn't make not that feasible, to be honest. Now that's the first thing, which is data. Now the next thing that we're going to talk about is they have something called sequence to sequence. So I'm going to write like this: sequence to sequence structure. That's the second thing. Now it's easy. It's not that difficult. So if you talk about sequence to sequence, now here, what does it mean? This means it is as an image encoder, same like, but they have multi-modalities encoder decoder when it comes to text. Earlier, when you talk about Florence-1, if you look at the Florence-1 research paper, it was 12-layer transformer, which is nothing but a similar to BERT model, and that's what it is. But here it is different. So image encoder, this remains same in both the cases, but this becomes multi-modality encoder decoder. So it's understand multiple dimensions, guys, encoder decoder. So this is sequence to sequence, same like Florence 1, but the only change in Florence 1 was, so let me just write it over here to highlight this. So I want you to read Florence 1 as well and understand. In Florence 1 they have a 12-layer transformer, 12-layer trans. So I'm just gonna write transformer like BERT for language encoders basically. That's what it is, sequence to sequence. Now that's the second thing, and we're gonna go into the nuances, guys, in a bit. We're gonna understand. Now the third is, this is a very high level, but let me just first write it down. Otherwise, I might forget a few points. Uh, the next is handling. Yeah, this is important because this is what they have highlighted. So they call it spatial hierarchy, and I'm gonna talk about spatial hierarchy. So I'm just writing spatial hierarchy and semantic granularity. So let me just write it over here. Granularity, right? Now this understands the layout. So I'm going to write layout and relationships. Let me give you an example. What do we mean by this? The semantic granularity. What do we mean by this when you talk about this keyword? Uh, Now imagine if we talk about a high level concept. So I'm writing high level concept, and then I'm writing detailed description. So let me just do that here. So detailed description. Now imagine we have a person. This becomes a high level concept that you are talking about a person. But if you add something called eating a burger, then this becomes a detailed description. That's what semantic granularity is, which is capturing high level concepts to detailed description. That's what it is. Now, spatial hierarchy is nothing but the layout and relationships or relationship of objects within an image. That's what a spatial hierarchy is. Now the next is, let's go into the technical nuances a bit to help you understand these concepts in a bit depth. So I'm just going to write here technical nuances. So let me just write here first. The first is vision encoder. Which vision encoder does it use? So it uses David, which is nothing but dual. So it's dual attention vision transformer. Earlier, if all these models, if you have used with, VIT, vision transformers, if you have worked with CLIP and NG, etc., they are different. But this uses David, which is dual attention vision transformer. It's basically what it does. Very interesting, guys. What it does, it basically creates, not creates, it basically transforms. What it does, imagine you have images. Now it takes the images and then it basically transform them into visual token representation. And it's not that as simple. Let me give you an example. So visual token representation. Now what do you mean by it? Imagine if you have an example. So example of an image. I'm going to write image of a park. You have image of a park. Now here it can be series of tokens. as it is dual attentions. So series of tokens. Now, how can, as a human, how can we perceive or how can we say that, okay, this is the particular image is of a park. So you're gonna look at some features, you're gonna identify a few things. So the first thing that you're gonna identify, probably a tree, a set of trees, and then different benches and people. So these are the few things that you see, right? And if you look at image of a park, that's what that's what David does when it takes images and then it converts into visual token representations, okay, of series of tokens. So that's what David is. Now the next point is, let me just write the next point, which is multimodality encoder decoder. So I'm gonna write MMED, which is multimodality encoder decoder, that integrates the, so first thing that you get this visual token representations, right? You get it. So it basically what it does, it representations are nothing but the embeddings, guys. By the way, I'm just going to write it here. Later you can say what does it mean by representation. Nothing but the numerical representations. Now with MMED, what it does, it integrate, you have the visual now. So you have the visual tokens embedding. So what it does, it basically integrates with text embeddings. So it integrates with text embedding and then processed by a transformer based MMED. That's what this does. Now the next is optimization. So they uses cross entropy for all the tasks when it comes to loss. So I'm just writing here, which is again unified architecture. So I'm just writing here optimization objective. In the optimization objective, they used cross entropy loss for all tasks. So basically what it does, if you think about it, this basically brings consistency. That's what it does, for optimization objectives. Now, some of the use cases, because if you are someone who is not that technical, you're gonna mainly focus on the use cases. Now, the use cases can be diverse, guys. The one can be on surveillance system. So if you have surveillance, my spelling is wrong, but you can understand, right? Surveillance system. The other is you can also use this in autonomous vehicle. You can also use this in AI assistant for visual question answering, and you can also do that in some R&D. If you look at all these new mobile phones, right? Samsung with S24 Ultra or something, or Pro. I forgot the exact name of that, but it has something where it takes an image. You can just segment that particularly, and then it goes on Google and search the exact thing. So basically, it can also do it in image. It can also help you with the search engine, in images, search image engine in fashion industry. The last is evals. Evals are important. Then we go into the fine tuning. I hope I didn't lose the runtime. Okay, I didn't lose the runtime. Let me just run this, guys, by the way, but just to make sure that's running. A100 is difficult to keep a hold, guys, on Colab Pro. Now on the evals performed really well. So which is the best model, guys? One of the best model, which is one of the most famous model, when it comes to multimodal or vision language model. Do you guys know that? How many vision model you guys know except Lava? There are a lot of vision models, guys. We have IMP v3, we have Idefix, we have Flamingo by DeepMind, if I'm not wrong. Yeah, if I'm not wrong, yeah. And then we have Idefix 2. Then we came Lava, we have Florence, we have a lot of other vision models that you can talk about. Flamingo is one of the most rated earlier, but now there are a lot of other things are overtaking. So uh, when you talk about object detection and how do we measure accuracy when it comes to object detection, did you guys forget or you guys remember it? It's based on map, guys, mean average precision. So if you talk about the COCO dataset, uh, let me look at the number. So it has a average precision, mean average precision 37.5%, which is better, when you compare that with other model. The next is captioning. So if you look at the COCO caption, the same data set, COCO is a data set, by the way, in computer vision, if you are not aware. ImageNet, COCO, Flickr, blah, 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 Kinetics. Oh, I hope you were If you're aware of this, if you are not aware, then don't be like a lockdown kid where you just started learning generative AI, not focusing on the fundamentals and basics of the AI ecosystem, starting with statistics, probability, machine learning, computer vision, natural language. Don't directly start with LangChain. That's my suggestion for you. Uh, Now, the Coco caption has so to talk about captioning. It has based on CIDER. That's an evals metrics for captioning, and it has got based even I think it's by Carpathes if I'm not wrong. But anyway, you can check it out. I forgot. Now it has 135.6, which is greater than Flamingo. Flamingo has 84.3 when it comes to CIDER, and Flamingo is a 80B model, guys. At least 10 times bigger than Florence-2 almost. And then we have Flickr. So Flickr, I hope you know Flickr. Again, a captioning. And when it comes to captioning, you do it recall. So it's at 84.4 recall. And then last can be text VQA, which is for visual question answering. A downstream thing has got around 81.5%. So this is on evals. Okay, and I have written it over here, but I'm not explaining. So we started with Coco here. You can see we started with object reduction, which is map, Coco 37.5, Coco caption 135.6 greater than 84.3, ATB model, Flickr, and text VQA. This is what it is, guys. Now I hope you got a bit of idea of Florence 2. For me, Florence 1 was more fascinating because it was released 3 years back, okay, or 4 years back now, almost 3 years back. And for that year, the model was really progressive. Now, coming back to this, we're gonna fine tune, guys. Pretty easy. So let me first do one thing. You can see I have all the fine tuning thing coming in here, bits and bytes, for faster, just to keep a check on the memory consumptions and computational requirements. I'm using gradient checkpoint enable because I want to accelerate this training. And then I am loading the dataset Science QA by Derek Thomas, which is a question answer dataset MCQ. And then I have a multimodal instruct dataset class, which initialize the data, look at the length of data, pre-process the data, transform the data through this template, question, choices, answer. And then I have a data collation function, collate the data. And then I'm creating loaders, train loaders, validations loader, having a very small batch size and 8 gradient accumulations, again, GPU parallelism. Now, optimizer, I'm using AdamW with some learning rates. Epochs one, you can increase the epoch. And I have train and validations things going on here. You can see train and validations. That's what it is. So let me just come here, run this, run this, run, run this. And you can see it started training. It will take at least 2 hours, if I'm not wrong, while looking at it. So I'm not going to wait for 2 hours. Of course, you can push this. You can save this by model.save pre-trained and then again load the model to inference and you can push it to Hugging Face as well. Pretty simple. If you don't know how to push it to Hugging Face, you do not have to watch any video. You have to go to ChatGPT and ask how to push a fine-tuned model on Hugging Face. It will give it to you guys. You don't have to really, hustle about these things. They are pretty easy. So just push it to Hugging Face repo, load the model to inference it, and then you can again do your own benchmarking on your use cases based on the data that you have selected for fine tuning. So this is what I wanted to create in this video, guys. I wanted to help you understand about Florence 2, how it's different from Florence, which was released 3 years back, how you can inference Florence 2, how you can, how it is different and what are the technical nuances when you compare this with other current vision language models or vision models, and how you can also fine tune it, on a given data set. That's what I wanted to do in this video. If you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. I'll give this code on my GitHub repository, so that link will be in the video description. You can also join our Discord community, and I'll give that link in the description as well. If you have any question, thoughts, feedbacks, please let me know in the comment box, or you can also drop it in Discord. We're gonna help you solve that if you are facing any challenges. Okay, that's all for this video, guys. Thank you so much for watching. See you in the next one.